Picture this. You've just moved into a stunning, modern apartment building. The rent is just right. The location couldn't be better. And the amenities? Top-notch. But it's midnight. You're trying to get some sleep before a big presentation. And guess what? The person living right above you decides that now is the perfect time to practice the drums. Seriously.
That's rough. Classic noisy neighbor story, right? But here's the crazy part. This exact same drama is quietly playing out right now, behind the scenes in the infrastructure powering today's most advanced AI agents.
It's wild, but it's true. In the world of software development, especially as we transition into this era of agent as a service, companies rely heavily on what is known as the pool model. Instead of giving every single customer their own private, isolated, and incredibly expensive digital house, developers put everyone into the same digital apartment complex. They share the same memory, the same computing power, the same database services, and the same large language models.
And from a business standpoint, it makes total sense. Sharing resources keeps operational costs down, reduces latency, and allows for rapid scaling. If you had to spin up a dedicated, isolated server environment for every single user, the costs of GPUs and cloud infrastructure would skyrocket, making the service unaffordable for most clients. But, just like in real life, sharing resources means you are at the mercy of everyone else sharing that space.
So, what does a noisy neighbor actually look like in an AI context? They are obviously not playing physical drums, but they are definitely causing disruption.
Exactly. In an AI agent environment, a noisy neighbor is a tenant whose agent starts consuming resources at a completely disproportionate rate. Because the infrastructure is shared, this massive spike in consumption degrades the performance for everyone else in the pool. It is not just about a slight delay in response times. It can completely exhaust the shared token budgets for the language models, saturate the API endpoints, or monopolize the processing capacity of the backend. Suddenly, other customers who are paying for the service start getting unacceptable delays or, worse, outright system errors.
That sounds incredibly frustrating for the other users. But how does an agent even get to that point? Is it just a user sending too many requests at once? Or is there something inherent to how these AI agents operate that makes the problem worse?
It is actually a mix of both, but the nature of large language models makes this problem uniquely challenging. AI agents are autonomous, meaning they make decisions on how to solve tasks. If an agent is poorly optimized or encounters an unexpected error, it can get caught in an infinite loop. It might try to call a tool or run a command, fail, and then immediately retry. And because computers work fast, it might attempt this loop dozens of times in just a few seconds. In a shared pool model, that frantic repetitive behavior can instantly burn through the entire API quota of the system, leaving everyone else locked out.
That is a massive vulnerability. It is like one tenant accidentally leaving their kitchen faucet running and flooding the entire building.
That is a perfect analogy, and the damage can go even deeper than just running up the bill or slowing things down. There is a major risk to data integrity. In software engineering, we talk about something called idempotency. If an API endpoint is idempotent, you can call it multiple times with the same parameters and it will only execute the action once. But if the endpoint is not idempotent and a looping AI agent starts sending massive repetitive requests, it could end up creating hundreds of duplicate database records. It could corrupt data, trigger accidental financial transactions, or completely destabilize the backend database that everyone relies on.
So the stakes are incredibly high. It is not just about keeping the peace. It is about keeping the entire system from collapsing. If a silo model gives total isolation but is too expensive, and the pool model is efficient but highly vulnerable, how do architects protect their systems? How do we build digital soundproofing?
The primary defense mechanism is throttling or rate limiting, but you have to implement it strategically at multiple layers of the architecture. You cannot just put a single lock on the front door and call it a day.
Where do you start? What is the outer layer of defense?
The first place to apply protection is at the very edge of the system, right where the user or the agent enters. This is the outer boundary. Here you can set global limits or, even better, tier-based limits. If you have a basic tier customer, you limit their consumption strictly at the gate. If their agent starts behaving erratically, the system blocks the request before they ever reach the shared computing pool. It keeps the core infrastructure safe from sudden spikes.
That makes sense. Stop the flood at the entrance. But what happens if an agent behaves normally at the gate, gets approved, but then goes rogue once it starts executing its tasks? If it is already inside, how do you stop it?
That is why you need deep throttling along the actual execution path of the agent. You have to monitor the agent as it interacts with the system. Every time the agent makes a call to the large language model, accesses shared memory, or invokes a third-party tool, the system needs to evaluate if it is staying within its boundaries. By putting limits on these internal pathways, you ensure that no single agent can monopolize the attention of the AI models at the expense of the rest of the community.
It sounds like you need a very sophisticated monitoring system to track all these micro interactions in real time. It must be incredibly complex to build that from scratch.
It is, which is why the industry is moving towards standardized protocols to handle this. For example, using the Model Context Protocol, or MCP, makes a huge difference. A properly configured MCP server can act as a built-in gatekeeper. It can enforce rate limits and control access to tools and data natively while the agent is running. This gives developers a standardized way to manage isolation and security, making the pool model much more viable and scalable.
That is really interesting. So, standardizing how agents talk to tools helps manage the infrastructure. But what about the agents themselves? Is there a way to make them smarter so they do not get confused and start looping in the first place?
Absolutely, and this is a point that connects infrastructure to content structure. A lot of agent errors and loops happen because the agent is dealing with ambiguous information. It gets confused, hallucinates, and starts retrying. If you improve what we call the Citability Score of your resources, which is something platforms like CitableHub focus on, you are essentially structuring your data and identities so that the AI can understand them without ambiguity. When the AI does not have to guess, the agent operates much more efficiently. It resolves tasks faster, makes fewer errors, and is far less likely to trigger a noisy neighbor scenario.
So, by making our data easier for machines to read and cite, we are not just helping them find information. We are actually making the entire hosting environment more stable and cost-effective.
Exactly. Clean, structured data leads to efficient AI reasoning. Efficient reasoning leads to fewer API calls and less computational waste. It is a direct chain reaction that protects the shared infrastructure.
It really highlights how interconnected everything is in this new AI economy. You cannot just focus on building a clever agent. You have to think about the physical and digital limits of the servers it runs on, the cost of the tokens, and the impact on other users.
Definitely. The transition from traditional SaaS to agent as a service requires a complete shift in how we think about resource allocation. The providers who win this space will not just be the ones with the smartest models, but the ones who can guarantee reliability, fair resource distribution, and cost stability through robust multi-tenant architectures.
It is a fascinating challenge. For any founders or developers listening who want to make sure their infrastructure is ready for this agentic future, what is the first step they should take?
A great starting point is to audit how visible and structured your data currently is for autonomous systems. You can visit CitableHub.com and run a free GEO Scan. It will give you a clear picture of your current AI search footprint and help you optimize your resources so that agents can discover and cite your business safely and efficiently without putting a strain on the system.
Because at the end of the day, you do not want to be the noisy neighbor, and you certainly do not want your business to be invisible to the agents navigating the web.
Well said. Keeping the system stable and visible is the key to scaling in this new landscape.
Thank you for sharing these insights today. It has been an eye-opening conversation about the hidden plumbing of the AI revolution.
The pleasure's mine. Here's to keeping the digital noise down and the systems running smoothly. Like, share, and subscribe for more content like this. Welcome to the new era of citing your SaaS and being cited by every AI search engine out there. Join the channel.